All right, so we've all played around with AI, asking it simple questions. But what if we could go deeper? Today, we're going to talk about how to move beyond basic prompts and actually teach these models how to think, how to reason, check their work, and give us results that are not just good, but powerful and reliable.
Look, we know large language models are amazing, but here's the catch. When you ask a simple question, the AI often just makes a single quick guess. And while it sounds super confident, that guess can be just plain wrong.
Take this, for example. We ask, which is bigger, Congo or South Africa? And the AI comes back instantly, South Africa is larger than Congo. It sounds legit, right? Well, it's not. The Democratic Republic of Congo is almost twice the size of South Africa. So yeah, this is the exact kind of confident mistake we need to fix. So that's the big question, isn't it? How do we get the AI to stop just guessing and start, actually reasoning? Turns out, it's all about how you ask the question. There are some really clever techniques we can use to guide it. Okay, so the very first step is to get the AI to slow down. Instead of asking it to just jump straight to an answer, we're going to teach it to build a little foundation of facts first. We're going to make it gather its own evidence before it says a word. And this first technique is called generated knowledge. The idea is actually super simple. It's like telling a student, hey, don't just give me the answer, show me your work. We ask the model to spit out all the relevant facts before it tries to answer our original question. So let's try our question again, but this time with a twist. We first ask, generate some knowledge about the sizes of South Africa and Congo. And look what we get. The actual land areas, world rankings, all the raw data we could possibly need. It's all laid out right there. And now here comes the magic. We take those facts it just gave us, feed them right back into a new prompt, and ask our original question one more time. And with that context, boom, it easily gets it right. Congo is larger than South Africa. Problem solved. Okay, so that's great for straight-up facts. But what happens when the problem is a bit more complicated? What if it's a logic puzzle where there could be a bunch of different ways to get to the answer?
Well, the next technique is called self-consistency. And the idea here is pretty cool. You basically let the AI try to solve the problem a few different times, coming up with different paths to the answer each time. Then you just take a vote. The answer that shows up the most is probably the right one. It's kind of like polling a committee of experts that just happens to be the same AI.
But we can take this way, way further. We can go from just taking a simple vote to actually teaching the AI how to brainstorm. Like a chess master thinking several moves ahead, exploring different possibilities, and figuring out which ones are actually promising. And you can really see the difference here. On the left, you have those separate parallel lines of thought from self-consistency. But look at the right. That's tree of thoughts. It's not just a few straight lines. It's a whole branching tree. The AI can go down one path, realize it's a dead end, and then, and this is the key part, it can backtrack and try a whole different branch. This method, tree of thought, or TOT for short, is a huge leap. It lets the model really explore. It can come up with a few possible next steps, judge how good each one is, and like we said, even go back and try something else if it gets stuck. It's much closer to how a person would actually solve a complex puzzle. So to really see how powerful this is, let's use a classic puzzle, the game of 24. The rules are simple, you get 4 numbers, and you have to use basic math to make them equal 24. This isn't something you can just look up. It takes some real trial and error. And wow, just look at these results. A standard prompt gets it right about 7% of the time. Even those other advanced methods don't do much better. But tree of thought? It solves the puzzle correctly almost 75% of the time. It's not even close. 74%. I mean, let that sink in. We went from a less than 1 in 10 shot to a 3 out of 4 chance of getting it right, just by changing how we asked the AI to think. That's a game-changing improvement. So far, everything we've talked about has happened inside the AI's head. But what if the answer isn't in its training data? What if it needs to find new information? Well, the next step is to give the AI tools and senses so it can connect to the real world. And we do this with a framework called ReAct, which, as you can probably guess, stands for Reason and Act. This is incredible. It lets the model create a plan and then actually act on it, like doing a web search. Then it can look at the search results and update its plan. It's this powerful loop. Think, act, observe, and then think again. This example just shows it all. perfectly. The question is about an author. If the model only reasons, it just makes up a wrong date. It hallucinates. If it only acts, it finds the right facts but can't piece them together. But with ReAct, it thinks, it searches, it sees the result, and then it puts it all together for the correct answer.
And we're not just talking about text tools either. With multimodal prompts, we can literally give the AI eyes. It can look at images, analyze charts, scan documents, even look at things like X-rays to pull out information. Okay, so our AI can reason, it can strategize, and it can even use tools to learn about the world. But there's one last absolutely crucial piece of the puzzle. We need to make sure the answers it gives us are in a format we can actually use. We have to teach it to speak our language, programmatically. And that's where structured outputs come in. We can actually force the AI's response to fit into a perfect template, like a JSON schema. That means no more messy, unpredictable paragraphs of text. We get clean, perfectly formatted data that a computer can understand every single time. And the best part, it's incredibly easy to do. It's just 3 steps. First, you define the structure you want. Second, you just pass that structure along with your prompt. And third, you get back perfectly formatted, ready-to-use data. It's really that simple. Here's a quick peek at what that first step looks like. You're basically just creating a blueprint for the answer. Here, we're telling it to break a math problem down into a series of steps, each with an explanation and an output, and then a final answer. We're telling the AI exactly how to organize its thoughts for us. So let's just recap. We've gone all the way from simple, often wrong answers to teaching an AI how to build its own knowledge, explore different lines of thought like a detective, use tools to find new info, and then report back in a perfectly organized way. We're literally teaching machines how to reason, strategize, and act, which leaves us with a pretty big question. What on earth should we teach them next?